Now, up to this point, we've only been using for loops in association with lists. So we've been looping through the list and getting hold of each of the items in the list and then doing something with it, right? But we're not always going to be working with lists and using for loops. Sometimes we might want to use a loop completely independent of a list. And a good example of this is when Carl Gauss, the German mathematician, was just a child. When he was 10 years old, his math teacher gave him an exercise that she probably thought would tie him up for a little while. And the idea was to get him to add all of the numbers from 1 to 100. So 1 plus 2 plus 3 plus 4 plus 5, etc. All the way until 100. And even though she thought this would keep him busy for an hour or so, getting this young child to add up these numbers, and I can have some peace and quiet scrolling on Facebook, but unfortunately he came back to her within 2 minutes and gave her the answer. So how did he work it out? Well, he was actually a really smart kid, and he figured out that if you flip the numbers around, so 100 plus 99 plus 98, and you look at both of these two lines, you can see that 1 plus 100 equals 101, 2 plus 99 equals 101, 3 plus 98 equals 101. Basically, if you tie all of these numbers together, there's actually 50 pairs of 101. So he could simply just do 50 multiplied by 101, which is 5,050. And that's how he figured out the answer. But we can actually outshine Gauss because we can do this calculation in less than a minute just by writing a few lines of code. But in order to do this, we first have to learn about using for loops with the range function. Now, the range function is something that is really, really helpful if you want to generate a range of numbers to loop through. And the syntax looks something like this. So we've still got our for and our in keywords highlighted in blue. But instead of looping through a list, we define how our loop is going to work by creating a range. So in this case, I'm creating a range between A and B, and then I'm going to get hold of each number in that range and do something with that number. So for example, if I wrote for number in range, and then my range is going to be 1, 10. So this is going to be the range that I'm going to create between 1 and 10, and then I want to get hold of each of the numbers inside that range. And this is going to be between 1 and 10 and not including 10. So if I go ahead and print out the number that I create from my for loop, then you'll see that what happens is it prints 1, 2, 3, 4, 5, 6, 7, 8, 9, but not the last digit, which I've included here. So if I wanted all of the numbers from 1 to 10, I actually have to set a range between 1 and 11. And now when you run the code, you can see that it goes from 1 all the way up to 10. Now, by default, the range function will step through all the numbers from the start to the end, and it will increase by 1. Now, if you wanted to increase by any other number, then you have to add another comma to the end of it and specify how large you want the step to be. So let's say we change the step size to 3. Now, if I rerun the same code, you'll see that it goes from 1, and then it steps by 3 to 4, and then it steps by 3, and then it steps by 3, finally to 10. Now let's come back to the problem that I mentioned at the beginning of this lesson. How can we add up all of the numbers from 1 to 100 by using code? Well, it's going to involve the for loop, and it's going to involve the range function, because we're going to get hold of every number in the range between 1 and 100. So we need to write 101. Once we've got hold of all of these numbers, it's as simple as using an accumulator. So let's say total equals 0. And then inside the for loop, so that means indented, we're going to say total plus equals number. So now it's going to add every number in this range to the total starting from 0. And this is basically going to give us the sum of every number from 1 to 100. So let's go ahead and print it out and see if it matches Gauss's value. And there you have it, 5,050. So now that we've beaten Gauss at his own game of math using programming, let's head over to the next lesson and try to complete a challenge using the range function to see if you manage to internalize and understand everything we talked about in this lesson. So for all of that and more, I'll see you there. Click on 5.3, adding evens. The exercise is kind of similar to what Gauss had to do that I showed you in the last lesson. But in your case, I want you to calculate the sum of all the even numbers from 1 to 100, including 1 and 100. So, for example, it might be 2 plus 4 plus 6 plus 8 and so on and so forth until you get to 100. It's a little bit more complicated than what the 10-year-old had to do. And the important thing to remember is that there should only be one print statement in your output. It should just print the final total and not every step of the calculation. So have a think about how you might solve this challenge, pause the video, and try to give this a go. Alright, so there's actually quite a few ways that you could have solved this challenge. Now, one of the ways would have been using what we learned from the last lesson and the ability to create a range function using a different step size. I'll show you what I mean. So let's create a for loop where we say for every number in the range between 1 to 100, so that's 101, then we're going to do something with each number, right? Namely, we're probably going to create a variable called total, and then we're going to add each of the even numbers together and accumulate it inside this variable. Now, remember that I mentioned that the range function actually has a third thing that you can add to it, not just the start and the end, but also the step size. So we can change the step size to 2, and then now what it's going to do is it's going to go through 1 to 100, and it's going to increase the step size by 2. So that means if we print this range as it is right now, it's going to give us 1 plus 2, which is 3, plus 2, which is 5, and so on and so forth. But if we change the range to start off from 2, which is the first number that we have to start adding in our sequence, and then increase it by 2 every single time, then we end up with a range that includes all the even numbers up to 100. And I'll show you if I run this code right now. So the next part is simple. All we have to do is to add the number to the current total. So total plus equals number. And then finally, outside the for loop, we can go ahead and print that total. Now, when I go ahead and run this code now, it's going to give me just the total. Now remember that the indentation really matters, because if I have it like this, then it's going to give me the total for every step of the calculation, because it's now included in the for loop and will be executed for as many times as the for loop runs. But if I remove the indentation, then the for loop is just this, and this is outside of it, so it's only going to give it to me once everything has been done and I've got the final total. And it's the correct solution. But you might have also done it in a different way. You might have said for number in range 1 to 101, and you had some sort of another total, let's call it total 2, and started at 0. And then we say that if the number modulo 2 is equal to 0, so if it's even essentially, then we're going to add this number to the total 2. Finally, outside of the if and outside of the for, we're going to print the final total. And now if I just run the code, then you can see I get exactly the same number as before. So if you chose to solve this challenge in either of these ways, then you've succeeded. They're both right. And there's probably even other ways that you could solve this as well. But these two, I suspect, will be the most popular approaches. Now, in the next lesson, I've got another coding exercise for you. And it's probably one of the top interview questions that programmers get asked when they're being interviewed for a job. So head over there and give it a go. All right, guys, I've got a fun coding challenge for you today, and it is a problem called FizzBuzz. Now, this is probably one of the most asked questions at interviews for programmers because it tests the way that you think and it allows the interviewer to see how you use your logic to solve a problem. And the problem we're going to tackle is a children's game called FizzBuzz. Last time I checked, the programmatic solution was actually up on Wikipedia, so I recommend reading the Wikipedia article only after you've solved this programming challenge. The rules of FizzBuzz are really simple. Basically, you have a bunch of kids who sit around in a circle, and going clockwise, the first kid says 1, the second kid says 2, but then when a kid encounters a number that's fully divisible by 3, then instead of saying that number, he's going to say fizz. And when the number is divisible by 5, instead of saying the number, they should say buzz. And if the number is divisible by both 3 and 5, for example 15, then they should say fizzbuzz. So your program is going to replicate this for all the numbers up to and including 100. To start off, it'll probably look something like this. It's going to print 1, and then on the next line it'll print 2, and then fizz, because 3 is divisible by 3, and then 4, and then 5 is divisible by 5, so it's buzz, and then 6 is fizz because it's divisible by 3, and so on and so forth. This is what your program has to do. Take a look at the instructions, make sure that you understand what it is that your program has to do, and then pause the video and try to give this a go. All right, so the first thing we have to do is to create a range, right? So let's say that for number in range, and our range is between 1 and 100. So we have to include 101 in here. And what we want to do is we want to check whether if the number is divisible by 3, divisible by 5, or if it's divisible by both 3 and 5. Now, we could write our code by doing this in order, right? We could say if number modulo 3 is equal to 0, then it's divisible by 3. So you might think that you could write the code like this, but there's a crucial problem in the logic here. Namely that we know that the if, elif, else statements will stop once it's found one statement that's true. For example, if we take the number to be 15, 15 divided by 3 is equal to 0, so it's going to carry out whatever instruction is inside this if statement, and then it's going to be done with it. It's going to skip this one, and crucially, it's going to skip this one, which is what we really need. Instead of structuring our code like this, what you might have done, and what you should have done, is in fact have this at the top. So first check if it's divisible by 3 and by 5. And then if that's not true, then check to see if it's divisible by 5 and then divisible by 3. Or the other option works as well. You could do it like this. Because these two have no overlap in terms of the results, then it doesn't really matter. So now we can finally write our code. Because we can say, well, if the number that we're currently encountering is divisible by both 3 and 5, then we have to print fizzbuzz. If it's only divisible by 3, then we're going to print fizz. And if it's only divisible by 5, then we're going to print buzz. Now, that still leaves the remaining numbers, right? Because the remaining numbers, which don't fit any of the criteria, should just be printed out as the number. We can catch that quite easily with an else statement that catches basically every other number, in which case we're just going to print the number. So now if I go ahead and run this code, then you can see that all the way from 1 to 100, it's been able to work out which ones are fizz, which ones are buzz, and which ones are fizzbuzz. How did you get on with it? If you got stuck or if you don't understand why this logic matters, then I want you to try both versions that I showed you and see it step by step using the Thonny program, just as we did before. That way you can visualize what's actually happening in terms of the logic and how it's flowing from one step to the next to the next. Now, once you've done that, then go back to your exercise and try to complete it. It's really, really important that you don't just say, oh yeah, I understand now. It's a really good idea to make sure that your code actually works at the end of the day and to write the code yourself. So today we've learned all about loops and we're going to apply it in our final project. So that's what's waiting up for you in the next lesson. So head over there once you're ready. Now that we've learned all about loops in Python, we're finally ready to tackle our final project of the day, which is the password generator. Our program will ask us, how many letters would you like in your password? So I will say, I would like a long password, let's say 14. How many symbols? 3. How many numbers? 4. And it's going to generate me a password that is almost completely impossible to crack by any hacker, no matter how talented they are. So the project of today is to build this password generator. If you head over to this particular replit, password-generator-start, then you'll see that here I've already included for you a list of all the letters in the alphabet from A to Z, including the uppercase and lowercase letters. I've got a bunch of numbers and a bunch of symbols that are usually accepted by websites in the passwords. And I've also created the inputs that you saw when we did the demo. So it's going to ask us how many letters, how many symbols, how many numbers, and then you're going to turn all of that knowledge, as well as using these lists and what you've learned about loops, into the same password generator that you saw in the final demo. So have a play around with the final demo yourself, and then have a think about how you might be able to achieve this goal of creating a random password for the user based on the number of letters, symbols, and numbers that they want. Now, there's 2 levels to this project. You can either go for the easy version, where all you have to do is generate your password in sequence. So for example, if the user wanted 4 letters, 2 symbols, and 2 numbers, then it might just look like this: 4 letters, and then 2 symbols, and then 2 numbers. So they're in sequence, right? First you've got the letters, then you've got the number of required symbols, and then you've got the required numbers. So this is the easy level, and then there is the hard level. And the hard level requires you to generate the password in a completely random order. So instead of having it being letter, symbol, number, it should be maybe letter, and then a symbol, and then a number, then a letter, then a symbol, and then a number. But notice how this is completely random. Every single time you generate it, the order of where the symbols and where the numbers appear in your password are completely random. So for example, if you look at the demo version and I do the same thing, 4 letters, 2 symbols, 2 numbers, where the numbers and where the symbols occur are completely unpredictable. And every single time I generate a new password, it's going to switch it up again. So that's the hard level. I recommend trying the easy level first, and then once you've managed to do it, then take yourself up to the hard level if you think you're up to it. But remember that if you're doing the hard level, you might have to do a little quick Google around in order to figure out how to do something that you might not have seen before. But it's all part of the challenge, and I hope you'll take it on with vigor. So pause the video now and try to complete the final project. All right, so let's first tackle the easy level, where we're just generating a password with the required number of letters, and then the required number of symbols, and then the required number of numbers. So let's go ahead and tackle this one first. Now, we know that we've got these lists which we can draw from, and we know that we can use the random module to get hold of a random item from the list. So all we have to do is first get 4 random letters. So let's say that we had a password which just started out as an empty string. Then we can use a for loop to loop through all of the characters that we need to create for our password. For example, I might say for car, short for character, in the range of from 1 to the number of letters that the user wanted. So in this case, if the user wanted 4 letters, then it will be a range from 1 to 4, but not including 4. So it's actually from 1 to 3, which is only 3 characters. In order to modify this, we have to do what we did always before, which is just to add 1 to the end of our range. So now we're going to create a range based on the number of letters that the user wanted. And I'm just going to go along with the assumption that the number of letters equals 4. Let's just pretend that's what the user will enter. So then this range becomes 1 to 4 plus 1, which is 5. So the range is in fact going to be 1 to 4. For every single number in that range, from 1 to 2 to 3 to 4, I'm going to generate them a random letter, and I'm going to pick it out of this list of letters. To do that, I can either generate a random number and use it as the index, or you might have seen previously, I showed you the random.choice function. And inside this random.choice, we can pass a sequence, which in our case is the letters list. Then it will look through this list of letters and it will give us a random item from that list. So now that random letter is going to be something that we're going to need to add to our password, right? So we can set this equal to a random character. And now let's go ahead and just print it out. So let's say we want 4 letters in our password, and we can type anything for the other ones. But notice how when the for loop runs, it's given us some random characters that it's picked out of our letters list. So there's an A, there's a capital P, there's a D, and there's a capital J. How can we add each of those letters to our password? Well, we can use the string concatenation that we learned very early on in day 1. We can say password equals the previous password plus the random character. Of course, the shortened version of this is just password plus equals random character. And now let's go ahead and instead of printing the random character, let's print the password at each stage of the loop. And again, I'm going to choose 4 letters. And you can see that the first time the loop runs, I get an M. So password is equal to M. The second time I get a Q, so I add the Q onto the M. I get MQ, and so on and so forth until I get these 4 characters in the beginning of what seems to be my random password that's going to be generated. Now, if you wanted to, you can actually simplify this down to just one step. Because instead of having this intermediary, which is the random character variable, we can simply just replace it with the code, like this. So in this case, we're getting a random choice from our letters list. So we get a random letter, and then we add that to our password. Now that we've done that for the letter, then it's pretty easy to see how we can continue doing this for the symbol and the numbers. We just have to keep adding it to the end of our password. So let me quickly write out the code for this. So now when the user requests that they want 4 letters in their password, then we generate a range from 1 to 5. And then for each of those positions, we generate a random letter in order to fill the password. And then we add on the required number of symbols and the required number of numbers. And finally, we print out the final password. Let's go ahead and run this code. And again, I'm going to choose 4 letters, 2 numbers, and 2 symbols. And I end up with my final password, which fits exactly that criteria, and it looks pretty random. But the only problem is that if a hacker knew that you always have 2 symbols at this position and 2 numbers at this position, then it's very easy to crack that password, because in order to get the last digit, for example, they only have to try 9 different variations, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this just limits the strength of your password. In order to tackle that, you would have to tackle it at the hard level, which is how do you get a password that has all of these letters and numbers in a completely random order? To do that, we mentioned that you have to do a bit of Googling because it might require something that you haven't done before. But in essence, you've got access to everything you need to perform the logic. So if you haven't given that a go, then this might be a good time to pause and have a think about how you might structure the logic, or how you might create a flowchart to express this logic that you would want. And once you've done that, and if you want to see the solution and walk through it with me, then come back here and I'll show you how to do it. But first, give it a go. All right, in order to tackle the hard level, what we essentially need to do is, instead of adding each of these letters into a string, we actually want to add it into a list. So I'm going to copy all of this that's here, and I'm just going to comment it out, and I'm going to paste it under my hard level and work on it here. So instead of using a password string, I'm going to create a list, and to better describe it, I'll change my variable name to password list. So now, instead of using password to add each of these letters and numbers and symbols, I'm going to be adding it to my list. Now, to add things to a list, you can use the same syntax that you did with strings, which is to add the new item into the list and to update the old list. You might be more familiar, though, with the syntax which is append. And both of these work. You can use either of them if you want, but they'll end up doing the same thing, which is to add each of those things you've generated in the order that you've generated to your password. So we end up now with a list with 4 letters, 2 symbols, and 2 numbers, all stored as strings because of the quotation marks around them. So now that we've got a list, well, then we have to think about, well, how can we shuffle our list? How can we mess up the order of the items in our list? And that might take you to Google, and you might search for something like how to change the order of items in a list. And then we also have to add our keyword, which is Python, because there's obviously a lot of other programming languages. And we come up against our first Stack Overflow question. How can I reorder a list? Well, that sounds kind of like what I want to do, right? So if we scroll down, you can see that the way to do it is either using a for loop like so, or to simply use the shuffle function. This is a much simpler way because it allows us to update the existing list just by calling the shuffle function on it. And this one actually requires us to create a new list, and we have to create a bunch of random numbers for the order and then to reorder them using a for loop. So I'm going to go with this version, and let's try it out. Instead of printing password list, let's print the password list before the shuffle, and then let's use the random.shuffle and pass in the password list, and then let's print the outcome of that shuffle. So let's print the password list again. So now you can see that we've got a version before and then we've got a version after. So if I run my code and I write again 4 letters, 2 symbols, 2 numbers, you can see that previously it was ordered in the order that we added each of the characters. After the shuffle, they're now pretty much random. There's letters in random places, there's symbols in random places. So if only we could turn this back into a string, then we've got our password that's nicely shuffled. So how can we turn it back into a string? Well, we could simply use a for loop, right? We could say for each character in the password list, we're going to add it to a variable called password, which is going to start off again as an empty string, and then we're going to add to it. So we're going to say password plus equals each character in our password list. And now if I go ahead and just print my final password, I'm going to add a F string as well. let's say your password is, then let's insert the password. And now if I run my code, and let's say I want 12 letters, 3 symbols, and 4 numbers, then it's going to generate me an entire password that's completely randomized in terms of the orders of the symbols and the numbers. And I've now solved the hard part of this challenge project. Did that make sense to you? Did you manage to get it to do what you wanted to do? If you're at all confused about the code that we've covered here, then be sure to check out the final project that I've got here, which is the app generator end, and take a look at how the easy level is implemented, how the hard level is implemented, and try switching it around so that you really get to understand it. Try, instead of maybe getting the user to tell you how many letters, how many symbols, how many numbers, instead just define those yourself or use a random number of letters, numbers, and symbols. Play around with the code until it starts doing what you want it to do and it starts making sense. But I hope you had fun building this project with me today and learning all about loops. On the next lesson, we're going to be learning more about these things that we've been using a lot, which is Python functions. So I'm going to bid you good night for today, and hopefully I'll see you bright and early tomorrow, and we'll learn some new skills and work on some new projects. So that's all from me. Good night from Angela.